Hello, Mr. Richards here. Today's lesson is on solving equations involving absolute value. And before we read our question, let's read about reading math. The expression f plus 5 is read the absolute value of the quantity f plus 5. Now, I may actually just read it as the absolute value of f plus 5, but of the quantity f plus 5 works as well. And so we have our example evaluate the absolute value of the quantity a minus 7 plus 15 if a equals 5. So I'm going to substitute in 5 for a. 5 minus 7 plus 15. Now as I solve inside my absolute value first, just like I would solve inside parentheses, because this absolute value is treated as a grouping symbol, 5 minus 7 is negative 2 plus 15. Now the absolute value of negative 2 is 2. Plus 15 now is 17, and that is our answer. Now when it comes to solving absolute value equations, there's two cases that we need to consider. Case 1 is that the expression inside the absolute value symbol is positive or 0. Case 2 is that the expression inside the absolute value symbol is negative. I mean, when we look at something like the absolute value of x equaling 7, I have two possibilities for that. 7, it is true that the absolute value of 7 is, well, 7. Or that the absolute value of negative 7 is 7. So I need to consider when solving absolute value equations that my answer could be, or at least the expression inside the absolute value is positive or 0 or negative. Now, when we look at the equation, the absolute value of 2x minus 1 equals 7, we have two cases. We need to solve the equation 2x minus 1 equals a positive 7. We also need to solve for the case where 2x minus 1 could equal a negative 7. And so we need to solve both equations. In our first equation, if we add 1 to both sides, 2x equals 8. We divide by 2 on both sides, and x equals 4. What about in our second case where our value inside, the expression inside, equals a negative 7? Well, we can add 1 to both sides here. So same start, but then 2x equals negative 6. Then divide by 2 on both sides of this equation, and x is going to equal negative 3. So our solution for this equation, you can put this in the little braces, negative 3, comma 4. That is our solution set for this equation. Now as we go to graph it, we can draw a number line where we have negative 3, negative 2, negative 1, 0, 1, 2, 3, and sneak in 4 here at the end. Basically just going to graph a point here at negative 3 and at 4. And so this is my solution in braces, negative 3, 4 as the solution set, and my number line below. So we need to consider both cases with an absolute value equation. One where the expression is a positive number, or 0, and the other where it's a negative number. And one more small thing, if you wanted to check our answer here. If you put in negative 3 for x, 2 times negative 3 is negative 6. Minus 1 is negative 7. Absolute value of negative 7 is 7. What about 4? 2 times 4 is 8. Minus 1 is 7. And the absolute value of 7 is 7. Now, what happens when we're trying to solve an absolute value equation to get a negative answer? Well, this gets a little tricky, but if you think about it, it shouldn't be. What number can I put in for x here to get a negative 5? And go. Well, if you said 5, the absolute value of 5 is 5. Oh, I got it. Put a negative 5. Well, the absolute value of negative 5 is 5. There is no number that we can put in for x to take the absolute value of that and get a negative number. So, our answer then is the null set. There is no solution. Since there is not a single number we can put in for p, so that p plus 6, and the absolute value of that is going to be negative. Now in example 3, the average January temperature in a northern Canadian city is 1 degree Fahrenheit. The actual January temperature for that city may be about 5 degrees warmer or colder. Write and solve an equation to find the maximum and minimum temperatures. Well, let's make t our variable here. Now t is going to equal the temperatures. And t is actually going to equal both our maximum and our minimum temperature. Well, how can that be? You get to use absolute value. We can say that the difference between the temperature and 1 degrees needs to be 5 degrees. Let's see how that looks. The absolute value of the temperature, whatever that max and min is, minus 1 equals 5. So we're saying the distance that temperature is away from 1 is equal to 5. Now, when we go ahead and solve this equation, we need to think about case 1, where it's positive. So t minus 1 can equal a positive 5, or t minus 1 is going to equal a negative 5. Well, if I solve these equations, add 1 to both sides, and t is going to equal 6 degrees. And if I add 1 to both sides here, t is going to equal negative 4 degrees. And there's my answer. My low temperature, negative 4 degrees. My high temperature, 6 degrees. And if we just look at this on a number line, if we have our 1 degree Fahrenheit here, 5 degrees warmer, 2, 3, 4, 6 degrees gets me that 5 degrees warmer. Or looking backwards, if I go 5 degrees backwards, I get to negative 4 degrees. And so the number line proves how our absolute value equation works. So again, whatever our max or min temperature was, minus this average 1 equaled the difference there of 5, as it was 5 degrees warmer or colder. And when you go to test, if your minimum was negative 4 minus the average of 1 is -5, and the absolute value of -5 is 5. Put in your maximum temperature of 6. 6 minus 1 is 5, and the absolute value of 5 is 5. In our last example, we're going to write an equation involving absolute value for the graph. And so we have a number line here marked at -4 and marked at 6. And our study tip, find the midpoint. To find the point midway between 2 points, add the values together and divide by 2. And so we have the -4 and we have the 6. So as we look to find the midpoint here, we can add -4 plus 6 and then divide by 2. Well, -4 plus 6 is 2, divided by 2 is 1. So the midpoint is 1. Well, as we look, it is true that 1 is about 5 away from both 6 and -4. We are 5 spots away. And so what we're going to do with this, as we are 5 spots away from both, is to write the absolute value of a variable, let's call it y, and then we're going to say minus this midpoint of 1 is going to equal 5, as we were 5 units away. And that's our equation. The absolute value of y minus 1 equals 5. Now, if you wanted to check this, you could. If you just look at the equation that we just created and put in both the -4 and the 6. Well, -4 minus 1 equals 5. That turns into be a -5. And sure enough, 5 equals 5. Or we could take the other side. The absolute value of 6 minus 1 should equal 5. Absolute value of 5 needs to equal 5, and of course 5 does equal 5. So our steps to write an equation involving absolute value: determine the midpoint by taking your 2 points, adding them and dividing by 2. You find your midpoint. We can put that on our number line and then find the distance away your 2 points are from the midpoint. It should be the same. So that we write the equation, the absolute value of our variable minus the midpoint equals the distance away. That's it for this lesson on solving equations involving absolute value. Good luck.